let this be piston, and let me bring a spring here. So here air is present, here ideal gas. There's a initial. Okay, initially we can say that spring is relaxed, or let spring be, say, some elongated. So I have the spring is elongated, spring force will act. Then what are other forces? The weight of the piston, mg, the pressure force of a gas, P naught A, and the pressure of a gas will be PA. Initial pressure, volume be V1, temperature be T1. Initial pressure, let it be P1. If you want, okay, we'll write it. This is a P1. Now I'm going to supply heat. So what is this? Heat supplied. Let this cylinder be insulating one. Let's assume even the piston also insulating. What will happen? What actually happens is what we can put it here. So again, if I go back to this, the piston will okay, this is elongated, no? Let me put it some initially relaxed, let it be. Now what will happen to the, this has raised by distance x or y, you take it, okay, along y axis we are doing. Atmospheric pressure force P naught A, spring got compressed kx, the weight mg will act, weight of the piston, pressure force of a gas P into A. Okay, this is what heat I separate. The temperature of gas T2, volume is, let it be V2. The pressure of gas, it has become P2. Okay, no. So what is the state of piston? It is at, I supply it, the gas will expand. When it expands, so what it does? So when it expands, so what it does, it will push the piston up, and here gravity is present, mg we are taking, gravity is present. Okay, let's see that. First, what is work done by the gas? So let's get expression for pressure at equilibrium. PA minus P naught A minus mg minus kx equal to 0. Will I agree? Of course, pressure is P2. Or, okay, we'll do one thing. Let it be right. So this is expression for pressure of a gas. Will I agree? Because of, look at the equilibrium. At equilibrium of piston. Okay, no, fine. So this is at equilibrium of piston. What happened? We see like this: PA minus P naught A minus mg minus kx equals 0. What is work done by the gas? Okay, this is what I'm interested. Work done by gas in any process. What is work done by gas? Integral of P dV. That's all. In any process. And what is the expression for P here? P naught plus mg by A plus kx by A. So expression for P will be into dx. So let it get displaced. Okay, let me take y only, yeah, because so it's a natural length. Let's assume. Okay, this is thing. So work done. So this will be P naught 0 to x. Let the piston undergo displacement. Oh. Let the piston undergo displacement of x. You can see it. The piston got shifted up by x. Now look at the atmospheric pressure force. It also does work. The weight does work. Spring force also does work. So everything will be P naught x. So this will be Okay, P naught x. So this will be mg x by E plus kx square by 2a.
Sir,
Yeah.
sir, work done by gas is integral of PdV, na sir.
Okay, yeah.
You wrote dx in the next step.
Okay, okay. One thing. Change in volume. It should be like this. Huh? Change in volume is a into dx, no? So then after integrating, okay, I think, okay, yeah, fine. This is what now dimensionally correct. Okay, no, look at this. So change in volume of gas. So the volume of gas has increased. Okay, I think okay, A dx it is. Change in volume is A dx. So I substituted pressure. Change in volume is A dx. What is the area of cross section of piston? Okay, just make observation. This is a fundamental, this is a theoretical one. Based on this, we have plenty of numericals. First, we have to understand. Okay, this is the thing. So tell me what happened. What all work done by gas? A part of it is used to compress the spring. A part is used to rise the potential energy of the piston, and the remaining is used to do work against the atmospheric pressure force. This is what happened. So we'll explore. We'll write it. What is meaning of this one? Work done by gas. What it is equal to? Work done against atmospheric pressure force. Work done by gravity. Okay, better right. This is work done by atmospheric pressure. Work done by gravity. And what is this? Increase in elastic potential of spring. Okay, what all the extravagant, what all the gas does work, what will happen? A part of it is used to overcome the atmospheric pressure force. A part is used to rise the potential energy of the piston, and the remaining will be converted into increase in elastic potential energy of the spring. Getting the idea? So this is what means now work done by the gas where it has gone converted into these three forms. Are you able to understand? So in chemistry, better let me not talk anything. So in physics, what happened? We must give account who will take that work done by gas. Somebody either here who is that somebody? These three agents. These three agents are consuming. Okay, let's do one thing. If there is no atmosphere, tell me what will happen in that case. First case will take it P naught 0. Let's assume that there is no air. So in that case, what is work done by gas? Work done by gas equal to mgx kx square by 2. Will I agree this? What all work done by gas, where do it has gone? Converted into increase in gravitational potential energy and increase in elastic potential energy. That's all. Okay, now second case, P naught 0 and the piston is massless. Then what is work done by gas? Converted into only increase in elastic potential energy of spring. Agree this? Third case, there is no spring, let's assume, and there is no atmosphere. So here, no spring, P naught 0, M0, and also no spring. Then what happened work done by gas? 0, because there's nobody is there to take the, though it has expanded, nobody is there to accept the work. So what is the meaning of this? Sir, we are not understanding the last part. It is like a free expansion. It is like a free expansion. This is the important core idea now, which we are generating. So altogether what happened? So this is the pressure, volume, temperature, P1. Okay, just okay, you do one thing. It's called like a free expansion. I'll supply heat. That heat what happen will be converting to increase in energy, but nothing will happen to the pressure. Work done by gas will be zero. Any reason for that? Because nobody is there to accept that work. Are you getting no? So when work done by gas will be non-zero, there should be some agent who should accept it. If there is no agent, then it will become free expansion. So volume V1, V2, it has absorbed free expansion of gas. Because any reason, because nobody is there. But sir, like you only said volume increases, work done by gas positive. That was the theoretical. Initially, I had to start like this only. Now we are at the end of the thermodynamics. So what is work done by gas? Only when somebody should be there to accept it. If nobody is there, work done will be definitely zero. Means now, can it happen like this? The fourth case, M0 no spring. Then in that case, work done by the gas will become equal to how much? P naught AX. Then work done by gas, who will take? The air. The atmosphere will accept it. It can be. Then if there is no spring, P naught zero, then work done by the gas converting to increase in gravitational potential. Are you getting the idea now? So here what happened? Work done by gas non-zero. Work done by gas here it is zero because no agent is available to extract or to accept work from gas. Are you getting no? So this is the reason what we can put it here. Okay, no. So what we have to do whenever in such numericals, tell me like what is the precaution we have to take it? Volume of gas increasing or decreasing? Yes, it is increasing. Then who is there to accept that work is what we have to ask it. Are you getting the idea? I'm there. Who is there? Atmosphere, the gravity, spring, friction, or kinetic energy of the piston. Somebody should be there to accept it. Nobody is there. Well, it's a free expansion. This will be a little bit very difficult for student to accept, but this is a condition. So in physics, what happens? We can give examples. We do have. Okay, I just okay. Let's start with the numericals. Okay, read the question.